Conclusion, recommendation, and perspective. Rhizobium bacteria are special bacteria that can live in soil or in nodule formed on the root of nodule, of the root of legume. Rhizobia are gram-negative bacteria, aerobic and non-sporulating. Rhizobia establish symbiosis relationship with several grain legumes and as a host plant. The important use of chemical fertilizer, pesticide, and fungicide have resulted in the deterioration of soil health and also harmful effect on soil biota. In agriculture, 80% of biologically fixed nitrogen comes from symbiosis involving leguminous plant and bacteria of Rhizobium, Rhizobiaceae family. The problem is that if Rhizobium make nitrogen available to plant, how farmers continues to use chemical fertilizer and organic fertilizer for that specific crop production. This problem statement helps us to ask several research questions. The first is, what are different species of Rhizobium bacteria found in leguminous root of phaseolus vulgaris in Bamenda? What would be the characteristic of this Rhizobium bacteria? How Rhizobium bacteria can represent an alternative solution to nitrogen chemical fertilizer in agriculture? The main objective of this study is to isolate and characterize Rhizobium bacteria from nodule root of phaseolus vulgaris species that can be used to produce a coefficient nitrogen biofertilizer based on symbiotic nitrogen fixation principle. The specific objective of this work is to collecting and describing nodules in different stages of development, is isolating Rhizobium bacteria in root nodule of phaseolus vulgaris and characterize them morphologically, multiply those Rhizobium bacteria isolated and formulating substrate for ulterior use, proposing the pedagogy relevant to this work. To attain all these objectives, several material and methods were used. To the collection of nodules was collected in 3 different periods: in the branching stage, flowering stage, and fruiting stage. Some parameters like shapes, weight of nodule were measured each time in the laboratory, accompanied by images. In the laboratory, to isolate the bacteria, the Rhizobium bacteria, root nodule peak in color were sterilized in 95% ethanol for 10 seconds and then washed 7 times with sterile distilled water. After that, the nodule was ground in a laboratory mortar with a few drops of distilled water. The concentrated juice was stripped on yeast exterminator agar containing 7 ml of Congo Red. After that, after incubation for 3 days at 30 degrees Celsius, single colony were selected and restricted in yeast exterminator agar. After isolation of yeast exterminator agar plus Congo Red, the colony was restricted in yeast exterminator agar and incubated for 3 days. This is for characterization. After this, we observed the morphology characteristics of several colonies, and we did the first dam staining test. After that, we selected colony and restricted in yeast exterminator broth, and 2 different techniques were used to check the quality of bacteria, like gram staining test and measure of optical density. Our planning material was first of all sterilized before using to produce our biofertilizers. In the process of biofertilizer development, 80 ml of yeast exterminator broth were lined with sterile charcoal powder and incubated for 24 hours. After that, the biofertilizer, the quality of Biofertilizer was checked before packaging in sterilized polyethylene bag. Concerning statistical analysis, Microsoft Office Excel 2019 and PRINT software were used to keep coding and analyze data collected during this study. Concerning the result of complete, this result shows that nodules have three main periods of development, like branching stage, where the root system was observed with the appearance of very small whitish nodule of spherical shape. In the flowering stage, wave of nodules increase and they become pinkish color. In the fruiting stage, when pod and seed are formed, the size of the nodule is very large during the maturation phase. Our results are in line with those conducted on soybean grow. We started that the rate of nitrogen fixation by nodule change with plant growth. Another author said that nodules begin to fix nitrogen and at the expression of hemoglobin chains. Concerning the morphological characteristics of isolated bacteria isolated from the yeast nodule rebel fast growing in 72 hours in YEMA+ Congo Red. They do not absorb Congo Red. They are translucent mucoid, bulging in Petri Dish. This study was first of all, this study is similar to D.I.P.E.S in 2018, who said that Rhizobia have the particular of producing acid in the presence of mannitol as a single source of carbon in the medium. The acidification is highlighted by the use of a pH indicator, in this case, Congo Red. Concerning the characteristic of bacteria in yeast extra mannitol agar, the strains were found the fast growing. All strains are motile and shape. Only on YEMA are root shape, non-spreading, translucent, convex, motoid in texture after 48-hour incubation at 30 degrees Celsius. These results are similar to ANO et al. 2021. They show higher motoid after 3 days of incubation at 28 degrees Celsius. This colony is also circular, smooth, pink, and opaque. Concerning the gram staining test, performed on 2 different media, liquid and solid, show that are colored pink. According to the principle of the gram staining technique, these bacteria are gram negative. According to data et al. 2015, Teresa and et al. 2021, those who did similar study, this description is consistent with the bacteria of the genus Rhizobium. Concerning the biofertilizer, these 3 bags of 225 grams, 165 grams, and 155 grams of Rhizobium biofertilizer were produced. The mixture was stored at the temperature of 4 to 15 degrees Celsius for a maximum of 6 months. Analysis of the physicochemical property of charcoal powder showed that it would be a good substrate for biofertilizer because it contains few quantities of nitrogen, phosphorus, potassium, and moisture. It also maintains the good viability of bacteria. Our result is an agreement with Eman et al. 2013, who reported that the formulation of an effective inoculant is multi-step process, which results in one of more strength of microorganisms contained in a particular carry together with sticky agent of the additive, which help in the protection of the cells during storage and transport. This is a biofertilizer. You can see the biofertilizer we have produced through this work. As a pedagogy relevant, the course that we developed after this studies is biofertilized agricultural production. This lesson can be inserted in upper 6 curriculum. This lesson will be able students to understand the concept of biofertilizer in general, understand the process of biofertilizer production in general, and how biofertilizer can be used to enhance the production of consumable food. In conclusion, the morphology of root nodules of beans to develop, the morphology of root nodules of beans begin to develop in the branching stage, followed by flowering stage and fruiting stage, during which the color, shape, and weight change. The bacteria strain isolated from the root nodule of beans on YEMA+CR alga do not absorb Congo Red and is a gram-negative bacteria. This bacteria is genus Rhizobium. Preparation of this inoculant of Rhizobium and inoculant carry for the development biofertilizer is seems to be essential for substitute the synthetic chemical fertilizer. Inoculant carry with charcoal. In this context, charcoal powder can also prepare for commercial purpose as the nitrogen biofertilizer. Recommendation: we advise farmers to use nitrogen biofertilizer for leguminous production. To explore in the research to explore another culture media for Rhizobium multiplication and carrying material that are locally available and low cost for biofertilizer formulation. In the Cameroon government, to increase the budget for research, we emphasize in the production of biofertilizer sector in order to reduce the importance of chemical fertilizer, importation of chemical fertilizer in Cameroon. Perspective: we suggest to our research team to continue this work through the isolation of Rhizobium from several leguminous to produce large quantities of nitrogen biofertilizer, and explore how can we combine nitrogen fixing, phosphorus mobilizing, and potassium solubilizing microorganisms to produce a complex NPK biofertilizer. We suggest also to explore another culture method for Rhizobium multiplication in order to obtain a maximum number of isolate from the maximum number of isolate. Put in place carry material that are locally available and low cost for biofertilizer production. Thank you for your kind attention.
Thank you, Mr.